right, hey y'all, Mr. Kyle, Myers Mathematics, and let's just jump right into it. We are doing number 27, n squared over 2 to the n. It's kind of like the reverse a little bit, n2 versus 2n. Find the limit of each of the following sequences using L'Hopital's rule when appropriate. Well, 2 to the n, so we're figuring out the limit as it goes to infinity. When we say the limit of the sequence, if they don't say what kind of limit it is, then we're assuming it's a limit as it goes to infinity. So basically, what I would say is it just depends on how you want to solve it. Because when it comes to infinite limits, there's a really easy way to do these. And I'll probably just stick with putting this on this video and not the other ones because I want to keep these relatively short. But basically, if you've got sine, cosine, that's not a C, sine, cosine, -1, or some sort of constant, then you have a degree of basically 0. Whereas, if you've got a logarithm, you've got a degree that's something greater than 0, but it's small and it's getting smaller. Any kind of logarithm, especially log ln of x. Then you've got the degree is actually just whatever the power is, which would be x to the n power. So like polynomials and stuff, right? Then if you reverse it, you get exponentials, and the degree is somewhat increasing, I guess you could say. The degree is getting bigger, so the degree is increasing when you have exponentials. And then last but not least, if we have a factorial, so actually let me switch back to green and turn this one to turn this one to blue here. If we have a factorial, then I like to kind of write it like this. This is very hand wavy, as they say, but I think it works. So this would be like an x factorial. Okay, hopefully you guys can see all that. So basically, if you have something lesser on the top, something greater on the bottom, the limit will be 0. If it's the reverse of that, then the limit doesn't exist. If the types of functions are exactly the same, then you would divide the leading coefficients. And that's pretty much how it works. So on the top, you've got a yellow function. On the bottom, you've got a green function. Green beats yellow, so the limit's going to be 0. Now, as far as how to do it using a little bit more formal method, I guess we could use L'Hopital's rule. And we would say, okay, well, if I plug in infinity, I get infinity over infinity. So that's indeterminate form. So I could use L'Hopital's rule, and then I would take the derivative. So I'd take the derivative dn of n squared and 2 to the n. And then that would give me 2n over 2 to the n. The derivative of 2 to the n is 2 to the n. There is a little bit of like almost like a chain rule, times it by the ln of 2 here. And then we would do it again. So I would get indeterminate form again. So I do d dn and then d dn. And then that would turn into 2 over, and then that would be 2 to the n ln of 2 twice. So like ln squared of 2, I guess you could say. And then at this point, you would say, okay, well, if you have anything over some sort of function that is increasing, an increasing function, then that limit goes to 0. That's just like one of the rules of limits is if you have a constant in the numerator and you have something going to infinity in the denominator, then the limit would equal 0 at that point. So that's a little bit more formal. If you need to go more formal than that, let me know in the comments below. But that should be plenty. So hopefully that's been helpful, and I'll catch you guys in the next one. Don't forget to check out my 5 math mistakes everyone makes and how to avoid them. Link in the description below. It's on my website, myersmathematics.com. Blessings, y'all.